Oh, hi there. Welcome to week 2 of distance learning. I'm going to continue on with seasons where we left off. Thought I'd go over more diagrams and more explanations from what you see in notes and for what we went over last week. So this is a typical seasons diagram that you're going to get from really anywhere in the world. Someone's going to go over seasons. And what was in your notes was reasons for the seasons. And just by looking at the diagram, you can tell that there's 3 major reasons. So if you're ever drawing a blank, let's say in homework or a test, what are the reasons for the seasons? Let's say that's the question. Just look at the diagram, and the visual diagram gives away the answers. So let's look at Earth. So we have Earth at 4 different positions to mark the beginnings and ends of the 4 major seasons. But if you look at the Earth, it's not standing straight up, it's on a tilt. So reason number 1, tilt. Okay? All right. What else do we see? We see arrows showing that Earth is changing position in its orbit. So reason number 2, revolution. Okay? Now you actually need these 2 together. So let's say Earth was just tilted, but never went around the sun. If that was the case, we would be forever stuck in the same season. But in order for the seasons to change, we need tilt along with revolution, so Earth can get to the other side. See, when Earth is on the left here, the North Pole is leaning towards the sun, so that means the North is in more light. So we're hot, they're cold. We have summer, they have winter. But half a year later, we get to the other side of the sun, and now the North Pole is leaning away from the sun. That means the South is getting more light. So if they're hot, we're cold. Since I say where, because we live in the Northern Hemisphere. So we're going to have winter, and the Southern Hemisphere will have summer. Okay? So the tilt is really the reason why the seasons are opposite. And the reason they change is because we go around the sun, and that actually changes the location of what we call the sun's direct ray. And that's really what we went over on my last video. Okay, because if you remember, we draw in the equator here, and then the sun's rays, they're south of the equator. So this is winter. But then in this diagram, on the left side here, they're north of the equator. So this is summer. Now these 2 are either always going to be spring or fall, and they're a little confusing. So since Earth is a sphere, this looks like the entire thing is in daylight. Remember, there's that whole other side. So what this is, the daylight side in this diagram is facing the sun. That's why it's completely lit. While here, since we're looking at it this way, we're looking at the nighttime side of Earth. So that the other side isn't dead. So really these are kind of identical. And the sun's direct ray will hit the equator. Right? So everything will be equal when it hits the equator, because the equator splits north and south. So neither hemisphere will be too hot, and neither hemisphere will be too cold. And that marks the beginning of spring or fall. If you notice here, there's still a 3rd reason. So tilt and the revolution are the ones that most people get right away. And you kind of leave out the 3rd reason. But if I extend this axis infinitely, and extend this axis infinitely, would those lines ever cross? No, they won't. Therefore, they're parallel lines. And that's where the 3rd reason got its name. It's called parallelism. And we kind of take it for granted. This reason kind of gets overlooked. So the fact that Earth is always tilted in the same direction as it goes around the sun makes the seasons occur in a very predictable manner. All right? So we're always pointing towards that North Star, Polaris. And we call this parallelism. So those are the 3 major reasons for the seasons. What I'm going to go over now is some of the major diagrams you're going to see throughout this unit. So you're always going to have, let's say, continue with the one we just had. Sun right here. This was winter. Here comes spring. Then comes summer. And then comes fall. Now the reason I knew this was winter is because I put the North Pole leaning away. And this is all shaded in. Okay, and then we go around the sun like so. So if you're ever given a diagram like this, and you're asked to label the seasons, or give the name of the day, let's say this was A, this would be December 21st. And the clue would be that the North Pole is leaning away from the sun. And then all you have to do is make sure you know to add 3 months. So 3 months later for B would be March 21st. 3 months after that is June 21st. And then 3 months after that, so that would be C. And then 3 months after that is September 21st. When you get a diagram like this, this is a side view. We're trying to represent something in 3 dimensions, like space, but the problem is we have a flat surface. So on a diagram like this, always ignore the Earth above and below the sun. They're going to confuse you. Because you might think, oh wait, Mr. Rosencrantz said when the North Pole points towards the sun, it's summer. So you might think this is summer. What you always want to do is look at the ones on the side. So here, the north is leaning towards the sun, summer. Here, the north is leaning away from the sun, winter. Okay, now I'm going to do the same type of diagram, but I'm going to switch it. I'm going to put winter on the left and summer on the right. So you're still going to have your sun in the middle. So now I'm going to put the summer on the right. So half is day, half is night. But if this is summer on this side, now the North Pole is leaning towards the sun. We always go around the sun counterclockwise, so that doesn't change. But then when we get to here, the North Pole is leaning away from the sun. So look, it's in darkness. Okay? And then we're back to an equinox. And since this is facing away, the whole thing is dark. Right? So this is now summer. This is now the first day of fall. This is now the first day of winter. And this is now the first day of spring. Okay? Now something I want to make sure I go over, because this mistake happens often. These are just the beginnings of the season. So if I ask you, where is the summer season? It's actually this whole arrow. This is only the first day of summer. So this would be June 21st, right? July 21st, August 21st, September. So this arrow is fall. October, November, December. This arrow is winter. January, February, March. And this arrow is spring. April, May, June. All right? A couple more diagrams. Just a side view. So let's say the sun is here and Earth is here. Let's say this was a free response question. And I asked you, draw the tilt for summer. So then you would draw our axis so the North Pole is leaning towards the sun. Now, Just by doing that, I pointed this out in the last video, you can see that the north is in light, the south is in darkness. Okay? But never memorize one diagram, because I could give you the same exact thing, but I could put the sun on the right. So if I said, draw summer, that would be summer. See, they're exactly the same thing. So please don't memorize one diagram. Understand the concept. If the North Pole is leaning towards the sun, that is summer. So these are both summer. So if I wanted to make them both winter, nighttime, I will lean the North Pole away from the sun. See? All right? So that's it for today's lesson. I hope you understand it with a little more greater detail now. And once again, if you have any questions, please feel free to email me. Take care.